Hi everybody. The 2025 AMC 10A has just passed, and what a test! The problems were really interesting this time, and let's go through them. Okay, let's start with problem 1. The problem reads, Andy and Betsy both live in Mathville. Andy leaves Mathville on a bicycle at 1:30, traveling due north at a steady 8 miles per hour. Betsy leaves on her bicycle from the same point at 2:30, traveling due east at a steady 12 miles per hour. At what time will they be exactly the same distance from their common starting point? Okay, so here's problem 1. Wait, hold on. Um, okay, so we know, let's say that their starting point is point P, right? And Andy, he goes here at 8 miles per hour, and Betsy, she goes there at 12 miles per hour. But Andy has started at 1:30 and Betsy started at 2:30. So by the time Betsy starts, Andy will already have traveled for 1 hour. So that's going to be 8 miles. So he's already been 8 miles and then he goes. Okay, so let's say that the amount of hours that have passed since Betsy started is k. Then this length here will be 12k and this will be 8 plus 8k. And that's because the 1 hour has already passed, so that's why we have the 8 here. So 8 plus 8k is equal to 12k. So solving, we get k is equal to 2. And Betsy started at 2:30, so we need to add 2 hours, which gives our answer of 4:30, which gives answer choice E. Great. What a nice problem. Okay, now let's go into problem 2. Problem 2 reads, a box contains 10 pounds of a nut mix that is 50% peanuts, 20% cashews, and so on. A second nut mix contains a certain percentage of nuts, and at last, so this mix is added to the box, resulting in a new nut mix that is 40% peanuts. How many pounds of cashews are now in the box? Okay, so since there's 10 pounds of a nut mix, and there's 50% peanuts, P, then we know that there's going to be 5 pounds of peanuts because that's 50% here. And the other one, let's say that we're adding k pounds of it. We know that there's going to be 20% peanuts, right? So that's going to be k over 5 pounds of peanuts. Okay, and so once we add all of them, we want the last mixture to have 40% peanuts. And so what will happen is we have 5 plus k over 5. K over 5. That's going to be the total amount of peanuts we have, right? And we want that over 10 plus k. We want that to be equal to 40%, which is 2/5. So if we multiply this out on cross multiply on both sides, we get 25 plus k is equal to 20 plus 2k. And so it follows that k is equal to 5. And from the original statement, we know that there's 20% cashews. So there's going to be 2 pounds of cashews here. And we know from this problem statement, again, there's going to be 40% cashews here, right? So 40%, that's going to be 2/5 by 5, which is 2. And since there's 2 on both, and there's going to be 4, which is answer choice B, pounds of cashews. Great. Now let's work on to problem 3. How many isosceles triangles are there with positive area whose side lengths are all positive integers and whose longest side length has length 2025? So there's two different cases here. The first case is that we have some triangle like this, and there's 2025, 2025, and x. That's the first case. So basically 2025 is the side length where there's 2 of. And case 2, 2025 is the base, and these two are the same, like, so let's say y, y. And let's just assume that x and y are both not equal to 2025. Then we have a small case 3 where all 3 are 2025, but that's just one triangle. That's equilateral, so there's one here. And for this one, by the trivial inequality, a triangle inequality, we have 2y, which is the sum of these two, has to be greater than 2025. So y can, since it's an integer, it can be equal to 1013. And it can keep going all the way until 2024, because 2025 is the longest side, right? And y is not equal to 2025 because we're counting that here. And so there's going to be 1012 triangles in this case, because each value of y corresponds to one triangle. In this case, x can be equal to 1 and so on, because 1 plus 2025 will always be equal to greater than 2025, but it can't be equal to 2025, and it has to be less than that. So it can go all the way until 2024. So now we just need to add these three, which gives 3037 as our final answer, which is answer choice D. Nice. And so let's go on to the next problem. Problem 4. A team of students is going to compete against a team of teachers in a trivia contest. The total number of students and teachers is 15. Ash, a cousin of one of the students, wants to join the contest. If Ash plays with the students, the average age on that team will increase from 12 to 14. If Ash plays with the teachers, the average age on the team will decrease from 55 to 52. How old is Ash? Okay, so we know that there's a total number of 15 students plus teachers. So let's say that the number of students is represented by the variable s. Then we know that students here, teachers here. There's s here, and there's 15 minus s, because there's a total of 15 people. And let's say that the age of Ash's cousin, let's just say cousin. Oh, okay, let's just call it K. Then we know that since the average of the students was originally 12, then the sum of all of their ages will be 12s. So 12s plus k, which is the total amount of all of their ages summed, over s plus 1, that's going to be equal to 14, right? Because it increased to 14. On the other hand, the teacher's average an age of 55. So 55 by 15 minus s, that's going to be, and we have to add that to Ash's age, which is k, over 15 minus s plus 1, that's going to be equal to 52, right? So now we have this system, and if we multiply out, we get 14s plus 14 is equal to 12s plus k, so it follows that 2s is equal to k minus 14. And so now we can manipulate the second one. We have 52 times 16 minus 52s is equal to 55 times 15 minus 55s plus k. And from here we can move this to this side and move this also to this side. So we have 3s plus, now we have 52 by 16 minus 55 by 15 is going to be equal to k, right? And right now I'm just going to tell you that 52 by 16 minus 55 by 15, that's just going to be equal to 7. You can do this by factoring or just doing it. It's not that bad. So 3s plus 7 is equal to k. And we know that from here, k is also equal to 2s plus 14. Since we want to solve for k, we could solve for s and then plug it back in. But there's another way to do this, which is just multiply this one by 3. So 3k is equal to 6s plus 42. And just multiply this by 2. So 6s plus 14 is equal to 2k. And if we subtract these two, then we get k is equal to 42 minus 14, which is going to give us our final answer of 28, which is answer choice A. Okay, great. Let's move on to problem 5. Okay, so consider the sequence of positive integers. There's a lot of integers. What is the 2025th term in the sequence? Okay, so we have 1, 2, 1, 2, 3, 2, 1, 2, 3, 4, 3, 2, 1. Okay, so notice that this is on 2. Just notice that they're going in a peak, right? It goes here, and then it goes larger, and then it goes larger, and then like so on. This is going to be on the 2nd term. And notice that this is going to be on the 5th term. And the peak of the next one, that's going to be on the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10th term. Well, what do we notice about this, right? Well, these looks like the numbers that are k squared plus 1, where k is a positive integer. Well, we could just say easy plus. And we can rigorously prove this, but on the test, since we want to go faster, problem 5 is probably not going to be that complicated, right? So what we're going to do is just notice that it's k squared plus 1. And so the first peak is going to be when k is equal to 1, the second peak is going to be k equals to 2, and so on until k equals something, which is what the 2025th term we want to find. And so let's notice that so we know that the nth peak term will be k squared plus 1, right? And so and we know that for the first one, it's going to be first one, second one, third one, and the peaks are always one more, right? So it's all going to be one more than k. So the peak is going to be equal to k plus 1. And so we remember that at any time you go into a test with that year, you want to memorize that year's number. And root 2025, that's just going to be equal to 45. So 45 squared plus 1, that's going to give us 2026. And we know that the peak is going to be 45 plus 1, which is 46. So 46 subtract 1, because that was the 2026th term. We can get 45 as the 2025th term, which is answer choice E. Perfect. We could always have rigorously proved this, but this way works as well. So, and in the test you want to be as fast as possible. Okay, problem 6. This one in the test is notoriously hard to draw for me. And in an equilateral triangle, each interior angle is trisected by a pair of rays. The intersection of the interiors of the middle 20-degree angle at each vertex is the interior of a convex hexagon. What is the degree measure of the smallest angle of this hexagon? Okay, so like I said, this one's super hard to draw, but like, let's work it. It's a very nice equilateral triangle, right? So we have these rays that go like this. Not very good rays, but we'll have to do one. Okay, this is supposed to be a lot cleaner, but this is our hexagon here, okay? And so we know that this is 20 degrees, right? By what they told us, it was trisected, right? So this is 20 degrees. We also know that this is 20 degrees because it's trisected again. But what we also know is we know that this purple angle, that's going to be equal to 60 degrees because it's an equilateral triangle, right? So there should be 0 here. So since if we consider this triangle, that one, then we can find this angle here, right? That angle, it's just going to be equal to 180 minus 60 minus 20, which is 100. So this one is going to be 80. And so if we do this similarly for this side, we also get that this is 80. And that this is 100, this is 20, and once again, we get that this is 60, right? Because 120, that's 120, 180 minus 120 is 60. And then, so that this is going to be 120, that's going to be 120. So in a regular, this is not a regular pentagon, but in any pentagon, the sum of the angles is going to be 540. So 540, you have to subtract off 2 times 200, which is going to be equal to, hold on. Yeah, it's going to be equal to 140, right? So this is going to be 140. But remember, the question asks the smallest angle of the hexagon. So we know in a hexagon, the sum of the interior angles is going to be 720. And by symmetry, these two angles are also going to be equal to 140. So we need to subtract off 3 times 140, which is going to be equal to 300, and 300 by 3, since there's 3 of these equal angles by symmetry, that's going to give us 100, which is answer choice C. Great. Now I can go back to using black. And remember to stick around until the end of the video where I discuss what I think will the AME cutoffs and DHR cutoffs will be. Okay. So, now let's go on to problem 7. Suppose a and b are real numbers. When the polynomial x cubed plus x squared plus ax plus b is divided by x minus 1, the remainder is 4. When the polynomial is divided by x minus 2, the remainder is 6. What is b minus a? Okay, so now we need to remember something called the remainder theorem. Basically, when we're dividing by some f of x is a polynomial, then whenever we divide by some linear factor x minus k, the remainder will be f of k, and this is a theorem. And that makes sense, right? Intuitively, because if this is a root, and then it's going to leave a remainder of 0. And when we plug in k into there, if it's a root, then it's going to give us 0, right? So we can apply that to this problem. X cubed plus x squared plus ax plus b. So when we divide it by x minus 1, we just need to plug in 1, right? So that's going to give us 1 plus 1 plus a plus b is equal to 4, and a plus b is equal to 2. That's our first relation, and when we divide it by x minus 2, so we plug in 2, that gives us 8 plus 4 plus 2a plus b. That's going to give us 6, right? So 2a plus b is equal to negative 6. So we have these two, right? And just subtracting them gives us a is equal to negative 8, and then going backwards, b is equal to 10. So, and we can check that both of those work. So b minus a is equal to 18, which is answer choice E. Perfect. That was really quick. Let's go on so we have more space. Problem 8. Agnes writes the following 4 statements on a blank piece of paper. And those are the 4 statements. You can read them yourself. Each statement is either true or false. How many false statements did Agnes write on the paper? Well, okay, let's just write, this is problem 8. Let the first statement be 1, the second statement be 2, the third statement be 3, and the fourth statement be 4. Okay, and for this one we can just sort of guess and check on the number of false statements. If there's 0 false, then, well, all of those must be true, right? So at least 2 of the statements must be false, which is false. So that doesn't work. If there's 1 false, then, okay, let's suppose that the 1 false statement is this one. So let this be F. And that's gonna, why we chose that one is because if this one was false, then that would cause this one to be a contradiction. So that's why we chose this one to be false. And we know that it's true that at least one of these statements is false because this one is going to be the false one over here. And at least one of these statements is true, then that's true, right? Because this one was true, and then that gives us 2 of these statements are true, so that one's true as well. So this construction works, right? There's nothing that's wrong about it. And since this is the AMC, there's only one answer, so in this case it's just going to be 1 false statement, which is answer choice B. Okay, now let's keep on going. Okay, problem 9 now. Let f of x equals 100x cubed minus 300x squared plus 200x. For how many real numbers a does the graph of y is equal to f of x minus a pass through the point 1, 25? Well, this is a really interesting problem. Okay, so f of x minus a, we want that to pass through 1, 25. So if we plug in x is equal to 1, then that should give us 25, right? So f of 1 minus a, that's going to give us 25. But that's also equal to 100x cubed, which is 1 minus a cubed plus 300, that's subtract, sorry, minus 300, 1 minus a squared plus 200, 1 minus a. And so we just now need to solve this for a, right? And we can solve this, but since it's a 3, there's a 3 in the exponent here, we know that there's not going to be more than 3 solutions, so we can eliminate choices D and E. Now we just need to make sure that they're all real solutions, because the question asks for how many real numbers A. And now we can just divide everything by 25, right? Because 25, we can like make the numbers super small if we do that. And that just gives us 1 is equal to 4 times 1 minus a cubed, minus 12, 1 minus a squared, plus 8, 1 minus a. And, well, notice that we can substitute some y is equal to this. So y is equal to 1 minus a, since that keeps a real no matter what. A is just going to be equal to 1 minus y, which is, if y is real, then a is real. So 4y cubed minus 12y squared plus 2y is going to be equal to 1, right? Yeah, and we can actually solve this cubic because it's not that bad. And eventually we'll get a is equal to plus or minus, I think, 1 over root 3 just by observation. But this cubic, it's always going to yield a real solution, so there's going to be 3 solutions, and the answer choice is going to be C, which you can see here. I left it open for you, as you can see how to solve it. I just didn't want to use our time here. Okay, now let's go on to the next question. Okay, now let's go through problem 10. A semicircle has diameter AB and chord CD of length 16 parallel to AB. A smaller semicircle with diameter on AB and tangent to CD is cut from the larger semicircle as shown below. What is the area of the resulting figure shown shaded? And here I have brought in the diagram so we can work this more clearly. Okay, so we know that this is tangent, right? So let's let the center be O. Then the radius here, it's going to be equal to R, right? And we know that this is going to be 8 if we take the perpendicular bisector, which will always pass to the center O, which is a theorem, once again. And so by the Pythagorean theorem, since we know that this is 90 degrees, this will be root r squared minus 64, which is going to be here. Now it seems like we can't do much here, right? Because anything using power of a point will just give us r. But the tricky thing here is we don't even need to find the exact value of r, because the area of the entire red semicircle, if we just fill in the white part, that's going to give us pi r squared over 2, right? But then this part here, we can also solve for that right? That's going to be r squared minus 64 pi over 2, since we're taking the square. And if we subtract these two, that just gives us 64 pi over 2, which is 32 pi. So we actually didn't even need to find r. That's really sneaky, right? That's a cool part about this problem. And that's just going to give us the answer choice C. Okay, great. Problem 11 now. The sequence is 1xy's arithmetic. The sequence 1pqz is geometric, and both sequences are strictly increasing and contain only integers, and z is as small as possible. What is the value of all of them summed? Okay, so we have 1x, y, z, 11. 1, p, q, z, and so let's let this common ratio be r. We know r must be an integer since both sequences are contain only integers, and r must be positive integer since it's strictly increasing, right? So z is going to be equal to r cubed for some positive r in the set of z plus. And we know that z, if we let this common difference be a, then since a is also must be a positive integer, it's also going to be equal to 1 plus 3a, where a is an element of z plus 2. Okay, and now we can just try r is equal to 1. Well, r is equal to 1, that doesn't work, because first of all, a is equal to 0. Second of all, that gives us a constant sequence, and we know that it must be increasing. Now if we try as r is equal to 2, that gives us a non-integer solution for a, so that's not gonna work. R is equal to 3, that gives us 26 is equal to 3a, that's not an integer solution. But r is equal to 4, on the other hand, that gives us a is equal to 21, which does work. So our sequence will be 1 for PQZ part, it's going to be 1, 4, 16, 64. For the other one, it's going to be 1, 22, 43, and 64. And if we add all of that, that's 20, that's 65, that's 85 total already. 85 plus 64, that's going to be 149, which is answer choice E. Perfect. Okay, now let's do problem 12 about the passcodes. Carlos uses a 4-digit passcode to unlock his computer. In this passcode, exactly one digit is even, exactly one possibly different digit is prime, and no digit is 0. How many 4-digit passcodes satisfy these conditions? Well, the thing about this is that MA was really nice to let us know about the even condition, because they wrote the possibly different. So we can separate this into two cases. The prime that's used is going to be equal to 2, or the prime that's going to be used is not equal to 2. In the first case, then we've already used our even number, which is 2, since there's exactly one even number, and we've also used our prime. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. It can't be 0, and we've already used up our even ones, so all of these evens go away. We've also used our prime ones, which is 3, 5, and 7, so there's only 1 and 9 left for the other 3 digits. There's 4 places to choose where 2 goes, and 2 cubed ways to choose like the other 3 digits, what they're going to be. Are they going to be 1 or 9? And so that's going to give us a total of 32. Nice. And the other one, let's say that the prime is not equal to 2, so 2 cannot be in here. Then once again, we have these choices, and the prime, it can be 3, 5, or 7. It can't be 2 anymore. So there's 3 ways to choose the prime: 3, 5, 7, 2, 4, 2, because 2 can't be used. And for the even number, we can choose 4, 6, or 8. So there's 3 ways to choose the even number. And then once again, we have the other 2 to use for the other 2 spots. There's 4 ways to choose where the out of these 4, say these are the 4, there's 4 ways to choose where the prime goes. And then after that's chosen, there's 3 ways to choose where the even number goes, and then there's 2 squared ways, 1 or 9 for the other 2. This gives us 36 by 12, which comes out to 432, I think. Okay, and that's going to be the 432. And now we just need to add these two, which gives 464, which is answer choice D. Nice. Okay, now let's go on to problem 13. Wow, it's a long problem. In the figure below, the outside square contains infinitely many squares, each of them with the same center and sides parallel to the outside square. The ratio of the side length of a square to the side length of the next inner square is k. The spaces between squares are alternately shaded as shown in the figure, which is not necessarily drawn to scale. The area of the shaded portion of the figure is 64% of the area of the original square. What is k? Well, okay, so let's first just consider the outside square. Since we know a certain percentage, let's just let the outer edge be 10, because it's a percentage, and it really doesn't matter what the outside is. Then this inside square will have 10k as the side length, and the next one will be 10k squared, and so on, right? And this part is going to be shaded. Okay, and so this first shaded part, that's going to be equal to, the area of that's going to be equal to 10 squared minus 10k squared, right? Because it's the area of the outer square minus the area of the inner square. And this next part, it's going to be 10k squared minus 10k cubed squared, right? And so continuing on, the next one will be 10k to the 4th squared minus 10k to the 5th squared, and so on, right? And this k here, this is just going to eventually become a geometric sequence, and we'll see why. If we pull hold on. Let me erase that so we have space. If we pull the 10 squared out, we have 10 squared times 1 minus k squared. And if we once again pull the 10 squared out of here, we get 10 squared times k to the 4th minus k to the 6th. Wait, hold on. Did I do that right? Yeah, I think so, right? And so this is going to be equal to, this one's going to be equal to 10 squared times k to the 8th minus k to the 10th. And if we, and this is just going to go on so on. And notice that this one will be equal to 10 squared times 1 minus k squared times k to the 4th. If we factor it out, this one's going to be equal to 10 squared times 1 minus k squared times k to the 8th. And notice that each time it's just going to be increasing by this k to the 4th factor. So it's a geometric sequence. And so we know that the first term is just going to be this. So 10 squared times 1 minus k squared, that's going to be over 1 minus the common ratio. And the common ratio is going to be equal to k to the 4th. Since this is an infinite geometric sequence, and that's going to be equal to 64% of the area of the original square. But the area of the original square, since we denoted this sine length was 10, that's going to be equal to 64. And notice that this guy factors as 1 minus k squared times 1 plus k squared, and these two just cancel, so we have this in the denominator, and we multiply out. 64 plus 64k squared is going to be equal to 100, and so 36 over 64 is equal to k squared, or solving k is equal to 3/4. And that's going to be answer choice D. Nice. Okay. Now let's go on to problem 14. And problem 14, it reads, 6 chairs are arranged around a round table. 2 students and 2 teachers randomly select 4 of the chairs to sit in. What is the probability that the 2 students will sit in 2 adjacent chairs and the 2 teachers will also sit in 2 adjacent chairs? So let's just draw this out. That's the 6 chairs. And let's just number them 1, 2, 3, 4, 5, 6. The students, let's call them A, B, and let's call the teachers C and D. Well, we know that it's going to be up to rotation, right? Because rotation could cause stuff to be could cause stuff to be counted like weirdly. So let's just fix the rotations by without loss of generality, let student 8 sit here. So there's going to be these 5 different spots left, and they're all distinct. Just call them chairs 2, 3, 4, 5, and 6. So the teachers and student P, we need to put them, the total amount of possibilities is just to put them into here, right? Which is going to be 5 by 4 by 3. That's going to be the denominator of a fraction. Now we need to find the number of cases where the condition is satisfied, because this was the total number of ones without worrying about that. And for that, B could either be here or here, right? So there's 2 ways to choose which one B is in. Say B goes here. Then we can choose either this one, or this one for the 2 teachers to sit adjacent to, which is going to be 3 ways. But then the teachers could go CD here or DC here, whichever way you want. So that's going to be by 2, and we put that in the numerator, kill, that's going to be equal to 1/5, which is going to give us answer choice B. Nice. Now let's go on to problem 15. I'm gonna get it onto our notes pad here real quick. 15. Oops. Give me a moment. And ta-da, here's our figure. In the figure below, ABF is a rectangle, AD is perpendicular to DE, AF is equal to 7, AB is equal to 1, and AD is equal to 5. What is the area of ABC? Well, this is a very interesting problem, right? Okay, so we know that this length is equal to 7, this length is equal to 5, well, here, and AB is equal to 1. So why don't we call this X, right? So since this is a rectangle, CE is going to be equal to 7 minus X, right? And by the Pythagorean theorem, C is going to be equal to x squared plus 1. And since we know AD is equal to 5, CD will be equal to 5 minus root x squared plus 1. So we also know that this is, let's call this alpha. This is 90 degrees since that's a rectangle. So these two will be similar, right? ABC and EDC will be similar. And just looking at this angle here, this length over this length will be equal to this length over this length, right? So we have 7 minus x over 5 root x squared plus 1. That's going to be equal to root x squared plus 1 over x, right? Now multiplying out, we have 7x minus x squared. That's going to be equal to 5x squared plus 5. So 6x squared minus 7x plus 5, that's going to be equal to 0. Oh, hold on. Oops. It's not 5 times root. That's going to be 5 minus. That's what happens when you have bad handwriting. So we kind of need to redo this one. Redo that part. So we have 7 minus 7x minus x squared. That's going to be equal to 5 root x squared plus 1 minus x squared minus 1. And so these x, why is that? It's an x squared. So these x squares, they just go away. 7x minus 1 is equal to 5 root x squared plus 1. In that case, we get 49x squared minus 14x plus 1 is equal to 5x squared, 25x squared plus 25. Moving over, 24x squared minus 14x. That's a 1, right? I don't want to get tricked by my handwriting again. Minus 24, that's going to be equal to 0. And so if we factor this, we get, wait, hold on, let me write it over again. 14x minus 24 is equal to 0. To make this easier, let's just divide by 2 first. 12x squared minus 7x minus 12 is equal to 0. So if we factor this, then we get, hold on, yeah, that should work. 3x, 4x, hold on, that should be positive 4, negative 3, negative 4, positive 3. Yeah, negative 4, positive 3, right? Hold on. Oh wow, I made 2 silly mistakes here. It's gonna be a plus because when we moved that one over, this was minus, so this will be plus. Okay, I'll be more organized now. Sorry about that. So we have 12x squared plus 7x plus 12 is equal to 0, which factors as 4x, 3x. So we have that, if we factor this, we get, this should be 4, and this should be negative 3, which works because 16x, which is these two multiplied, and then these two multiplied, minus 9x, that's going to be equal to 7x, which is this guy. So this works. And this is going to give us a negative 1. This is going to give us a positive 1, so x is equal to 4/3. We want to find the area of ABC, and that's just x here, that's 1. So the area of ABC will be x over 2, which is 3/8, which is answer choice A. Nice. Okay, problem 16. A really nice expected value one. There are 3 jars. Each of 3 coins is placed in one of the 3 jars chosen at random and independently of the placements of the other coins. What is the expected number of coins in a jar with the most coins? Well, let's split this up into casework. Case 1, the most is 1. In this case, let's call the jars A, B, and C, right? And this is just going to be, the only way to do that is like this, right? Let's call these coins 1, 2, and 3. And let's assume that they're all distinct, because distinct sometimes makes stuff easier to count. And there's going to be 3 factorial ways to arrange these 3 coins. And that's going to occur with probability 1/3, because they're independent for each one to the cube. And so that's going to give us 2 over 27 times 3, which is 2/9. And since there's at most 1, then 2/9 by 1 is going to be the expected value for this case. Now we move on to case 2, A, B, and C. Well, then let's say that there's a most of 2. Then there could be 2 here and 1 here. Then to arrange these, there's one pile with 2 coins, there's one pile with 0, one pile with 1. So that's going to give us 3 factorial ways to arrange which pile gets which. And after we've chosen which pile gets how many coins, we need to split the coins into one being here. So there's 3 ways to choose that coin. And this occurs with, once again, with probability 1/3 cubed. And yeah, that occurs with probability 1/3 cubed. So if we calculate this out, we need to multiply by 2 because the most is going to be 2, right? So this gives us 1/27 by 18, which is going to give us 2/3 by 2. That's going to be equal to 4/3. Okay, now let's move on to case 3, which so I'm just going to circle these real quick so we don't lose them. Case 3, the most is going to be 3. Most is going to be 3. Then in that case, then that occurs, there's 3 ways to choose A, B, or C, but there's only one way to choose like the coins because they're all going to be in the same pile, right? So that's going to give us 3 by 1/3 cubed, but we also need to multiply again by 3 because the most is 3 here, right? So that's going to give us 1/3, and then now we can circle that again. Now we just need to add all 3 of these because that's all 3 of the cases. And adding that gives us 5/3 plus 2/9, which is going to be equal to 17/9, which is answer choice D. Perfect. Okay. Now let's do problem 17. Hold on. Okay, problem 17. And it reads, let n be the unique positive integer such that dividing 27, 34, 36 by n leaves a remainder of 16, and dividing 27, 27, 60 by n leaves a remainder of 15. What is the tens digit of n? Well, in this case, we know that 27, 34, 36, that's going to be congruent to 16 mod n, right? I'm going to use lowercase n because that's faster to write. And we also know that 27, 27, 60 will be congruent to 15 mod n. And in other words, 27, 34, 20 is going to be congruent to 0 mod n. And this one will be 27, 27, 45 will be congruent to 0 mod n. Okay, now that we've done these two, we know a fact. Since this is going to be congruent to 0 mod n is going to have to divide 27, 34, 20, or n is going to have to divide 27, 27, 45. Now, since the n divides both of these, n must also divide its difference. So, which is good because it makes the number smaller. So if we subtract these two, then we get n is going to divide this one, the bottom one minus by the top one. So that gives us 675, which is equal to 3 cubed by 5 squared. Okay. And there's a few things we can do here. We can test out different values of n and see which work, and then eventually work our way back, which is one way to do it. And that's the way I'm going to show here, but we're going to do it in a smart way. Looking at the answer choices, there's going to be 0, 1, 2, 3, or 4, right? So we know that some of the values that we're going to test, they aren't going to work since it tells us that n must be the unique positive integer. So 3 cubed by 5 squared. Let's test n is equal to 3. Well, actually we don't need to test that because since it leaves a remainder of 16, n must be greater than 16 to leave a remainder of 16, right? So let's try n is equal to, let's say, 25. Well, that obviously is already cooked because it already fails on the second condition. So now let's try n is equal to 3 squared by 5, which is the next smallest one. In this case, we really don't want to be dividing those large numbers by 45 because that's going to take a long time and we don't have time on the AMC. So what we're going to do is we're going to break this up into different parts. In this case, let's say we have 27, 34, 36, right? That's going to be congruent to something mod 9, and that's going to also be congruent to something mod 5. And mod 5, this is just going to be 1 because there's a 6 in the end. Mod 9, well, if we add these two, that's 9, so we ignore that. That's 7. 7 plus 7, that's 14. Leaves a remainder of 5 mod 9. 5 plus 2, that leaves a remainder of 7 mod 9. So this will be 7 mod 9. Okay, now we can use the Chinese remainder theorem, and we can write that number as 9k plus 7, right? And that's going to be congruent to 1 mod 5, so it's going to be congruent to 4. 9k is going to be congruent to 4, or well, 4k is going to be congruent to 4 mod 5. And this is for some arbitrary k, right? And solving this, we get k is congruent to 1 mod 5. Note that we did not divide. In fact, we just multiplied by 4 on both sides. We can't divide in modular arithmetic unless we're really sure about it, which is another condition and a story for another time. Okay, so since k is congruent to 1 mod 5, well then k can be equal to 1, right? So if k is equal to 1, then we get 16, and the number is going to be congruent to 16 mod 45. Whoa, that works. There's 16, and there's 16. Well, if we do it by, we can check the second number, and it also leaves a remainder of 15. So the answer is going to be 45. So the tens digit is going to be 4, which is going to be answer choice E. No, so the main idea was we just tried to find what n could possibly be, narrowed down the cases, and then use Chinese remainder theorem to speed up our calculations. Okay. Ooh, this one, 18. 18 was a really nice one. The harmonic mean of a collection of numbers is the reciprocal of the arithmetic mean of the reciprocals of the numbers in the collection. For example, the harmonic mean of 445 is what it says over there. What is the harmonic mean of all the real roots of the 40/50th degree polynomial product of k is equal to 1 in 2025? That thing, we just need to find it, okay? So it's actually not that scary. The product is just gonna be x squared minus 4x minus 3 times x squared 2x squared minus 4x minus 3, and so on. Okay, that's just gonna be the product. It's not scary at all. Well, let's let the roots of the 40/50 degree polynomial be r1, r2, r3, and yada yada yada. That's gonna give us all the way until r to the 40/50. And so our thing, it's gonna be 1 over the arithmetic mean, right? So 1 over 4050 because there's 4050 roots. 1 over r1 plus 1 over r2 plus yada 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 plus 1 over r 4050. Okay, and so this product here, we can like do stuff with it, right? Because that's the thing, that's the hard thing about the problem, right? So if we make the denominators common, then that's gonna give us r1, r2, r3 all the way to r 4050, and that's gonna be over r1, r2, r 4049 plus r1, r2, 4048, 4000, r 4050, and it's just gonna be like skipping one turn. And remember Vieta's formulas here. This will be negative to this, one of these will be negative, the other one will be positive since they're adjacent in Vieta's formulas. This will be the second to last coefficient in the entire expansion, this one here, and this one will be the last coefficient. And looking back up here, it's going to go all the way on until 2025 x squared minus 4x minus 3. And we know that exactly one of these two will be negative since they're adjacent, so we just like disregard that for now. Of course, if you really wanted to do it, you could find it. So this is going to be equal to negative times something, okay? And this top thing, it's going to be the coefficient of x. The bottom thing is going to be the coefficient of x to the power of 0. And since there's 2025 terms, the bottom term will be negative 3 multiplied by itself 2025 times. So that's going to be negative 3 to the 2025th, okay? And the other term, it's really interesting because if we have x squared in any of these, when we multiply anything by x squared, it's going to have at least an x squared in there. So we actually only need to worry about the negative 4x minus 3 part. So we could just disregard everything else and take this to 2025th power. We want to find the coefficient of x. And by the binomial theorem, this is just going to be 2025 choose 1 times negative 4x to the 1 times negative 3 to the 2024. So this is just going to be 2025 times negative 4x times negative 3 to the 2024. And now we can just clear these negatives. So we have a net negative, and this will be positive here, this term, the negative 3 to the 2024th. And if we just clear this and clear this, we get 3 in the denominator. So, and 2025, we know that that's going to be 3 to the 4th by 5 squared. So this just is going to come out to negative 3 cubed by 5 squared, right? And so now we can plug this in back into here. 1 over 4050 by negative 3 cubed by 5 squared. 4050, that's going to be equal to 3 to the 4th by 5 squared by 2 here. So if we clear it, let's just put the negative in front. 1 over, this kills, that leaves 3, this kills. Hold on. We had the negative 4 from here. Don't forget to bring that back. Oh, well, the positive 4 now. So we have the 4 here. So just never forget to check all your terms before you start combining. So we have, this is going to kill with this. So there's 2. And this will be negative 1 over 2 over 3, which is negative 3 over 2, which is answer choice B. Problem 19 now. An array of numbers is constructed beginning with the numbers negative 1, 3, 1 in the top row. Each adjacent pair of numbers is summed to produce a number in the next row. Each row begins and ends with negative 1 and 1 respectively. If the process continues, one of the rows will sum to 12,288. In that row, what is the third number from the left? Okay, so let's just write this out. Negative 1, 3, 1, negative 1, 2, 4, 1, negative 1, 1, 6, 5, 1. If we sum this row, that's going to give us 3. If we sum this row, that's going to give us 6. If we sum this row, that's going to give us 12. Notice that every time we multiply by 12. Why is this? Because we're just adding each of these. So if we do a bit of induction, we can prove that it's always going to be multiplying by 2. The sum is always going to multiply by 2 each time. So something sneaky is if we can call this the first row, second row, and third row, then each row can be represented by 3 times k minus 1, where k is the row number, the sum of the numbers in that row. That's going to be equal to 12 to, yeah, that. And if we divide by 3, that's going to give us 2 to the k minus 1 is equal to 4,096. And this is 2 to the 12, so k is equal to 13, and it's going to be in the 13th row. And now what we can do is we can use a smart way to find it, or if we really can't come up with a smart way, 13 is not that bad. We can actually just compute it if we really wanted to, which I will show here, how to be like organized. Negative 1, 2, 4, 1, negative 1, 1, 6, 5, 1, negative 1. Now we just need to add these two, so that gives us 0, 7, 11. The next one, we actually only need to care about the first 4 because we'd be looking for the third term, right? Negative 1, negative 1, 7, 18, negative 1, negative 2, 6, 25, negative 1, negative 3, 4, 31. Now we can just stay here, right? Because it really actually doesn't matter. Negative 1, negative 1, negative 4, 1, and 35. Negative 1, negative 5. We're just adding these, by the way. 3 and what is this? 36. And let's check how many we've done. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, hold on. Let's check our work real quick. Make sure that we're not doing anything wrong. Oh, this is negative 3. Yeah, so we did do something wrong. But that's everything else is good. Negative 1, negative 5, negative 8, 33, negative 1. Wait, how many did we do again? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10. So this is going to be 11. Now, negative 1. Wait, this was negative 6. Negative 14. And this is gonna give us, hold on, negative 14 is the next one. This is negative 7, negative 14. And 12 is gonna give us negative 1. Hold on. Negative 8, negative 21. And the last one, this is gonna be 13. Negative 29. So our answer is gonna be negative 29, which is A. Another way to do this without doing all this computation is just to use binomial identities. Both work. This way is just a way that avoids using complicated binomial identities. Okay, next one, problem 20. Oh wow, we got through this in about an hour so far. A silo, right circular cylinder with diameter 20 meters stands in a field. McDonald is located 20 meters west and 15 meters south of the center of the silo. McGregor is located 20 meters east and G is greater than 0 meters south of the center of the silo. The line of sight between McDonald and McGregor is tangent to the silo. The value of G can be written as A root B minus C over D, and the rest is just answer extraction. Okay, so let's just draw the, that's a circle, right? Let's place this here. Okay, we know that the radius is going to be of 10, right? So let's call this point O. Then this is 10. And so McDonald is located 20 meters to the west, and the west is this side. So this is good. 20 meters from the center, so this will be 10 as well, and 15 meters down. 15 meters. And south. McGregor is located 20 meters east, so on the other side it's going to be here, and G is greater than 0 meters south of the silo. So, like, let me first just draw the tangent. This is their tangent, right? So, this is the tangent point. This is going to be equal to G. We want to find G, right? If we extend this, we can actually do some stuff. Hold on. Okay, and we want to find G. We know that this is tangent, so this will be 10 as well. And that's pretty much our information, right? Oh, we're also given that this is 10. So there's a few different ways to approach this. A really interesting way is through similar triangles, right? Because there's a lot of similarity here. We can try that first, right? So let's let this length be x here. Then we know that since this is 90 degrees, well, let's use colors to draw this. Hold on, can I use, do I have a pointer? Yeah, so this triangle, that's going to be similar to this triangle, which is also similar to this triangle. And that's super cool, right? So we have these relations. Let's first find out what x is. So the hypotenuse of here, of the, let's call this OAB. So OA over OB, that's going to be equal to, let's call this C. AC over OA over OB over 15, right? And OB, that's just going to be 10. So if we multiply this out, we get 3OA is equal to 2AC. And notice that we can represent AC and OA both in terms of x, right? OA, that's just going to be equal to 20 plus x. And AC, that's going to be by the Pythagorean theorem, 2 times AC, which is going to be the square root of 40 plus x squared plus 15 squared. Now, if we square both sides, then we get that 9 times 400 plus 40x plus x squared, that's going to be equal to 4 times 1600 plus 80x plus x squared plus 225, right? Just checking my work real quick. Okay, and that's going to give us 3600 plus 360x plus 9x squared is equal to, hold on, 6400 plus 500, 900, I mean. So that's going to give us, hold on, 7300, yeah. 7300 plus 320x plus 4x squared. Moving this, we get 5x squared plus 40x minus, that's going to give us 3700, I think. That's going to be equal to 0, okay? And dividing x squared plus 8x minus 740, that's going to be equal to 0. Now we can apply the what is it? The quadratic formula. So we get negative 8 plus or minus the square root of 64 minus 4 times negative 740 over 2. That's going to be equal to x. And we take the positive one because if it's negative, x cannot be a negative length. Okay, so 64 plus 4 times 740, that's going to give us 3024. Take the square root of that, that's 12 root 21. So x is going to be equal to negative 8 plus 12 root 21 over 2, which is 6 root 21 minus 4. Okay? Okay, as you can hear, my throat is getting hoarse from all this talking. This is all happening in one recording. So we know the length of x now, and that's amazing. That's going to be 6 root 21 minus 4. That's really amazing. And now let's consider these two triangles. This triangle and this triangle. Those two are similar. So we know that, actually I'm going to point out again, this over this will be equal to this over this. Okay? So, 15 over g, that's going to be equal to this entire thing added together, which is 36 plus 6 root 21 over 6 root 21 minus 4, right? So now we can solve for g, right? And so multiplying out, 90 root 21 minus 60 is equal to 36g plus 6g root 21. And so, wait, we actually didn't even need multiply. So g is going to be equal to 90 root 21 minus 60 over 36 plus 6 root 21. And they want us in a specific form, so we need to clear the denominators, unfortunately. But before we do that, we can divide by 6. So g is going to be equal to 15 root 21 minus 10 over 6 plus root 21 multiplied by 6 minus root 21 on top and bottom. That's going to give us, on the bottom in the denominator, 36 minus 21, which is 15 over that multiplied by each other. If we do this, we get 90 root 21 minus 60 minus 15 times 21 plus 10 root 21, which is 100 root 21 minus, let's compute this real quick, 375. If we clear the same factor of 5, that gives us 20 root 21 minus 75, I think. Now if we add all of these, since all of these are relatively prime, 41 plus 75 plus 3, that's going to give us 78 plus 41, which is 119, I think, which is the answer choice A. Perfect. So the main thing in this problem was just realizing the similar triangles and drawing a pretty good diagram, which is hard to do on the test, but good if you can bring a ruler. Rulers are always amazing on the test. Just don't use them in the first 15, because those aren't necessary for the first 15. Okay. Now let's go to problem 21. Okay. I'm just gonna talk you through this because it actually doesn't really require that much work. A set of numbers is called sum-free if whenever x and y are not necessarily distinct elements of the set, x plus y is not an element of the set. For example, 1, 4, 6 and the empty set are sum-free, but 2, 4, 5 is not. What is the greatest possible number of elements in a sum-free subset of 1, 2, 3 all the way to 20? So the answer is 10. Really, you don't even need to write anything down. It's pretty easy to see that 11, 12, all the way to 20, that's just literally just going to work, right? Because anything added together, even the smallest, that's going to be greater than 20. So this is a working construction. It's 10. So 10 is a working construction. And to show that anything above, we can use the pigeonhole principle. On the AMC, time is low when you're at 21, so it's good to just circle 10 and come back later to rigorously prove it if you have time. But here I'll just offer a really quick explanation for why. Suppose that we choose all of the odd numbers work too, all the way to 19. If we choose anything in between, even 18, these odd are just separated by 2, so we can always get the number that we have. Or more concisely, 1 plus anything, that's just going to give us an even number. So that's a quick explanation for why. Okay, now let's do problem 22. And it reads, a circle of radius r is surrounded by 3 circles whose radii are 1, 2, 3, and 3. Are all externally tangent to the inner circle and to each other, as shown. What is r? Well, this problem is actually trivialized by an Olympiad geometry theorem called Descartes' kissing circles theorem. Basically, it says that when any 4, in this case, any 4 circles, if they're all mutually tangent to each other, then their radiuses, say r1, r2, r3, and r4, 1 over them, this will be equal to 2 times squared squared, squared. And so notice that we can just plug in our numbers and get the r, right? So we get 1 plus 1/2 plus 1/3 plus 1 over r squared is equal to 2 times 1 over 1 plus 1/4 plus 1/9 plus 1 over r squared. And so we get 11 over 6 plus 1 over r squared is equal to 2. 4 plus 9, 13 over 36 plus 13 over 36. That's going to give us 49 over 36. And that's going to be added to 1 plus r squared. The squared is supposed to be inside. And just solving this, that just gives us r is equal to, I'll leave you to the details. R is equal to 6 over 23, which is answer choice B. Great. Yeah. And sorry about that, but I think my voice is getting a bit hoarse today. So I'll stop recording here and we'll get 23, 24, and 25 done in next time. Thank you so much for watching. But before I leave, I'd like to give some cutoff predictions for this test. Overall, I thought it was about the same difficulty as 2022, maybe a bit easier. But the first few questions were actually time sinks and took a lot of time. So my prediction for the AMC cutoff will be around 90. The lowest it could be is probably around 93. The highest it could be, I'd say 100. And for honor roll, I'd say the lowest it could be is 105. Highest it could be would be around 120. And for distinguished honor roll, I think it'd be around 129 as a low, and as a high it could be 136. But other than that, I think these are pretty nice questions, and I hope that you guys all enjoyed my video. See you guys next time.